Hello, my dear students. This is Felix Balaji. Today, let us discuss JEE Mains 2026 January shift question paper in the evening shift. Already in the last video, we have done 1 to 5 questions. In this present video, we will do 6 to 10 questions. Sixth question: RMS speed of hydrogen and oxygen are same given. Temperature of oxygen is given 23 degrees centigrade. Temperature of hydrogen gas they are asking. We know RMS velocity formula root of 3 RT by M. Here for both the gases, RMS velocity is same, 3 are constant. So then M is directly proportional to T, we can say. So molecular weight of first gas by molecular weight of second gas equal to temperature of first gas by temperature of second gas. First gas is hydrogen gas, its molecular weight is 2. Second one is oxygen, its molecular weight is 32. Equal to temperature of oxygen given 23 degrees centigrade converted into Kelvin. So temperature of hydrogen they are asking, so T1. Solve this one to find T1 value. This question belongs to CR circuits. For a given circuit arrangement, find the charge on the capacitor in steady state. At steady state, so current through capacitor will be 0. So current through capacitor becomes 0. The whole current should pass like this. So this current, so pass through this diode because this is forward bias. But this diode is reverse bias. Through this, no current flow. That means the whole current will pass through this only. So the circuit will be redrawn like this. So this is 2.5 volt battery, internal resistance 1 ohm, and here we have a capacitor, but in steady state there will be no current through capacitor, no need to worry, here no current flow here. And here, so forward bias, diode forward bias, it acts like a wire. Here only we have 3 ohms. So the whole current will passes through 3 ohms like this. Now current equal to formula total voltage 2.5 volt by total resistance 3 plus 1 4. So I value becomes, so 2.5 can be written as 5 by 2 by 4, it is 5 by 8 amps. Now I can find voltage across this resistor. V equal to formula current into resistance 3. So we'll get V value as 15 by 8. So this voltage will be equal to voltage of capacitor because both are parallel. So voltage of capacitor equal to 15 by 8. Charge on the capacitor formula Q equal to C into Vc. So capacitance given 5 micro, Vc value 15 by 8. Simplify this one to find charge value. Let's go to next one. This question belongs to atoms. An electron hydrogen-like atom has energy equal to minus 0.04 E naught, where E naught is the magnitude of energy of this electron in the ground state. Energy is given as minus 0.04 E naught. We know energy of electron in an atom is minus 13.6 Z square by N square electron volts. For ground state, I should keep N value 1. So then energy becomes E value minus 13.6 Z square by N value 1 electron volts. Here it is given, for ground state, this energy is equal to E naught given. Now divide both of them. So you will get E by E naught value. So when you divide, Z will cancel, 13.6 cancel, you get 1 by N square you will get. Here you can see E by E naught value becomes 0.04. We have to take only magnitude only. So this will be equal to 1 by N square. This can be written as 4 by 100 equal to 1 by N square. Apply square root both sides. This becomes 2 by 10 equal to 1 by N. From this we can get N value as 5. But here we are asked to find 2 pi L by h value. Here L is angular momentum. 2 pi by h, angular momentum formula was nh by 2 pi. Here 2 pi will get cancelled, h will get cancelled. So you'll get simply n. N value already we got here 5. So that's your answer. Come to next question. During SHM, kinetic energy of particle SHM varies with the frequency of 176 Hz. Find the frequency SHM of the particle. For a particle in SHM, the total time period is T. So time for one oscillation will be like this. But if you observe carefully, at mean position, kinetic energy will be maximum. At extreme position, kinetic energy will be minimum. Again at mean position, kinetic energy will be maximum. The repetition of kinetic energy takes place after half the time period. That means for kinetic energy, period of rotation is T by 2. When time period is half means frequency will be doubled. So frequency of kinetic energy will be double the frequency of oscillation of the particle. So frequency of kinetic energy is given 176 Hz 2 into frequency of the particle. So particle frequency becomes 88 Hz. This question belongs to work per energy. In this, position of a particle of mass 2 kg varies as a function of time is given. Find out work done on the particle from 2 seconds to 3 seconds. So you are asked to find work done and position given. So from this position equation, if you differentiate, you will get simply velocity. So V equal to formula dx by dt. So V becomes 2t plus 1. If we keep t value 2 seconds, you will get initial velocity 5. If we keep t value 3 seconds, you will get final velocity 7. Now according to work energy theorem, work done due to all the force equal to change in kinetic energy. K final minus K initial. Final kinetic energy formula half mv square. Initial kinetic energy formula half mu square. You can make half m common. So v square minus u square. Substitute m value, u value, v value. You will get fourth option.